good evening. My name is Jim Milam and this is my shop, and I welcome you all here. Today we're going to talk about chisels and planes, and I'm going to spend most of the time on planes, but we're going to do chisels first. What I have here is a bench chisel, bevel edge. It's a very wide one. There's not many uses for this, so I call it a special purpose one because of its large size. This is a piece of banding that I use quite a bit. I made the banding. When you use this banding, the corners are mitered. So how do you miter this? Well, I have here a block of wood. I have 45 degrees on this corner, and I have 22.5 degrees on this corner for occasions when I need that size. I take this banding like so, put it here, push it forward. If you can zoom in on this, I'll use this very sharp chisel and cut a miter. And I can inch it forward maybe 1/1000th of an inch and shorten it. And here's what I cut off. It looks like a shaving, very, very small. This is the chisel we used in a previous video. And this is my definition of sharp. Chisels and planes need to be this sharp. Here is a plane iron, an extra plane iron I have. It does the same thing. That's my definition of sharp. Some people shave the hair off their arms. This is what you need to, this is your goal. I have here a chisel plane, and I wanted to show this because it shows what a low angle plane is. You can see the brass is the bed and the steel is the iron. This bed is at 12 degrees. This plane here is at the same angle. This chisel, of course, a chisel plane is for getting into tight places where this one won't reach into. These both are bevel up. This is a number 4, bevel down. This bed angle is 45 degrees. That means that since the bevel is up, this cutting angle is 45 degrees. I can change that cutting angle by changing the frog, which I'll do. Take off the cap iron, remove the iron. Here's the frog. I take this out, put this in, and it's going to bed about right here, 5 degrees more. 5 degrees doesn't sound like much, but it makes quite a bit of difference. As this blade gets more, the incline increases, it gets steeper, it gets more difficult to push. This low angle, if you think about the logic of it, if I wanted to plane this bench, it makes engineering sense. The lower the angle, the easier it is to push and the more effective it would be. The higher the angle, if this went up like so, get more difficult to push and be less effective. But you reduce tear out. Any wood that has a difficult grain, we increase that angle, we have less tear out. So if we increase that angle enough, we end up with one of these, which is a scraper. This angle you can see is, if this is 90 degrees and this is 12 degrees, I'm going to put this scraper about, 70 degrees. Clean up my bench. No tear out. This is a number 80. This is one of these scrapers in a holder. It does the same thing. The advantage of this is, if this were a tabletop, I can see a place that's torn out. I can clean it up, but I can also dig a hole. One's about as bad as the other. But because of this sole here, I will not dig a hole with this. This is a number 85 scraper plane. It is fixed at 70 degrees. 90 degrees being here. This one's at 70 degrees, and it Does the same thing, but maintains a flat surface. This is the same thing, a scraper plane. Does the same thing, but this one has the ability to change the angle, get more aggressive or less aggressive, but it accomplishes the same thing. And this, of course, is a number 112 scraper plane. Also, the angle can be changed, and of course, the projection below the sole can be changed. Accomplish the same thing. This is a Bailey, Stanley Bailey number 4, and this is a Bedrock, Stanley Bedrock number 3. The only difference between the two planes is really the width, the size, but there's a functional difference. I'm going to take them apart. Like so. This is the Frog. You can see, if you look this way, they're both the same pitch, 45 degrees from the planing surface. If I want to plane something and move a lot of wood really fast, what I want to do is open the throat of these planes so I can accommodate a thick, aggressive cut. But to open the throat, I have to move this Frog back. This Bailey plane, if I want to move the Frog back, I have to remove this iron. Then I have to loosen these 2 screws here, slide the Frog back or forward, wherever I want to move it to, tighten them up again, put it back together, like so, adjust the plane, advance the iron, fettle it out, this being the Bedrock. If I want to open the throat, there's 2 screws that hold the Frog fixed in the casting of the plane. I can turn these screws. Now there's a screw in the middle that I can reach in this way and turn to the right. It advances that Frog, which will close the throat, or if I turn it to the left, it'll back the Frog out and open the throat. When I get it where I want it, I tighten these screws back. What that allows me to do is I can almost test it. I'll close it a little more. I can do it very easily. But there's one other difference, a really big difference. If I take these apart, here we go. The way this works is this machine surface beds against this machine surface. But on this plane, this being the Bailey plane, this machine surface right here and this little surface right here beds against this surface and this surface. Now, there's a lot more metal to metal here than there is here. This was a more economical plane to buy. It was priced so that anybody that wanted one could afford it. But this was the premium plane, and those are the differences between the two. They basically weigh the same. The iron is the same, but how the Frog works and how it beds is much better over here than it is here. Better in the sense that vibration of the plane in motion will give you ripples in the board you're planing. That you do not want. So weight, mass, metal on metal, tightly screwed together will eliminate vibration or minimize it. That's the goal here. This is a piece of cherry, and it's warped or twisted. You cannot build anything with any sort of accuracy until this board is flattened. How do we determine twist, and how do we determine when it's gone? Well, obviously you can lay the board down on a known flat surface, such as my workbench, and I can tell it's twisted. What if I didn't have a flat surface big enough? What if this board were 18 inches wide and 12 feet long? How would I judge its degree of twist, or if there is any twist, and then how do I measure when I get it out. So what we have here is winding sticks. This is 2 pieces of maple, roughly 1.5 inches thick. One of them I have a piece of, I think that's ebony, that's let in, and it's let in such a way that I can get it out by removing these screws. I can put this stick back here and this one up here. And by the way, these 2 sticks need to be parallel to each other. The bottom and top of each stick needs to be parallel, and you have to be maintained parallel. If they get out of parallel, the whole effort is wasted. It's give you a false reading. So I can put these up here like so. I can put them anywhere. I can read, if this board were 20 feet long, I could read it on one end and go out 3 feet, check it, go out 6 feet and check it, whatever. But in this case, I'll demo this at about, it's almost 3 feet long. So what I would do is come around to the end, sit down or kneel down or bring my eye level down so I can look across the top of these 2 sticks. And what I'm seeing is that the far right corner is much higher than the far left corner, because those lines are not parallel. If the far left corner is low, the near right corner is low. I can move the stick like so, raise it up, and I can tell, hey, there's a 1/4 inch or so of twist in this board from end to end. So what I do is I take a piece of chalk and mark. I need to take wood off here and here. What I have here is a shooting board. 2 pieces of plywood with a bench hook with a hook on this end, so it registers here, doesn't move when I push against it, and a fence on this end which is square to this line, and I mean dead square. And what I want to do, here's a piece of mahogany, and I want to square this corner. So I've got 3 planes here I can do this with. This is a number 62, which is the equivalent maybe of a number 5. This is the bevel up. The number 5 would be the bevel down. Put it on its side, and it works like so. I'm going to push against the plane with this hand and against the wood with this hand. And I'm going to take off a shaving. I get this edge straight and smooth. Turn it over, I want this edge against that. But before I do, I want to knock this corner off right here. So I put a little bit of space over here. I'll knock this corner off. And the reason for that is, when I turn it over, I don't want to blow blow it out on this side. So I knock the corner off just a little bit. And I can see when that little piece I knocked off is gone. So I can clean this up, just like so. And you see the shavings? Now this is a plane. That's the end grain. It's probably not 1/1000th of an inch thick. Both of these surfaces are ready for finish and is square. Now I can do that with this bottom up plane. I can do it with this larger number 6 bevel down plane. This is taking a much deeper cut right now. Works the same, but there's a plane that's made for this. This is a number 9. It's a little heavier. It has what's called a hot dog, which is much more comfortable. And by the way, this hot dog will fit on this number 62. You can buy it separately, but this plane comes with it, and it works just the same way. And it's a surefire way of getting this surface 90 degrees to this surface, and to get this surface straight. And this chute board can be designed so you're running this way, and you can make it as long as your bench, and just stand over there and you walk along with it. What I have here is a piece of mahogany. It's maybe 18 inches long and 9 inches wide. And there's a little bit of twist in it. This corner's high and this corner's high. But I can see the bandsaw marks where it was sawn from at the mill. And what I want to do is hand plane it and flatten it. I look on the side and I see the grain is running this way. So I want to plane this way. So this is the way I put it in here. And this tail vise will hold it steady for me. Over here I have a number 4, number 5, and number 7. I'm going to use them in this order. 5, 7, and then 4. The difference is the size. I'm going to set for a rather deep cut because I want to move wood quickly, and I can advance this fast. Now these are the three planes that I recommend if somebody wants to get into using planes. These are the three of the. I've got 40 planes over here. These are the 3 I would recommend you buy.
All that 45-degree swap.
They're all identical except for size. You can change the frog out. You can buy this plane from Lee Nielsen with one of 3 pitches that they offer. But these are all 45. A little more than I can handle. I'd much rather do this than go to the gym. The result is about the same except to have a board that's flat when I get finished with here. And it is a workout, no doubt about it. Now I'm going to number 7. The number 5 gave us a surface that has some peaks and valleys. This long plane will bridge over the valleys and knock the tips off the peaks simply because of its length. It's also wider. All I've got to do is advance the iron. Now, I'm starting now to go at this in a systematic manner. As I move across, move back across, move back and forth, I overlap about 1/3 of the width of the plane on each pass. Put a little paraffin on here. Reduces the friction. Except for this right here, which is quite deep, and that's about all I can do with this plane. Now I go to the number 4, and this is a smoother. I'm setting it for a very, very light pass. Take a very thin shaving, and it just smooths the surface. I can smooth it with this one, but it's flat enough. This has done its job. So this plane is sharper than that one. Throat is tighter. And it'll just improve this finish. See, I'm taking a lighter cut. Back the iron off just a little bit. Okay, now that board is flat, smooth. You can sand it if you want to, but you will not improve the finish at all. There's no snipe. There's no other way to get a piece of wood this smooth than with these planes. Now I could have done this over on my joiner. My joiner's wide enough to do this. You get a washboard surface, even with the segmented head on it. If I ran it over there first, and sometimes I do the rough work over there and come over here and plane it. I enjoy doing this. There's no noise. Really there's a little bit of dust with this wood, but it's not up in the air. I enjoy the peace and quiet, so that's what planes are all about. Some people shave the hair off their arms. I don't like blood particularly. This was sold as a chisel, but it is no longer a chisel. It is a paint can opener. Raleigh Johnson, he has a series of videos on how to refurbish, fettle, clean up, and use these planes. So fine woodworking videos on antique planes by Raleigh Johnson.